Boy, I'm about my business on business. I drink liquor on liquor. I had women on women. Yeah, that's bump bad bitches. I done live more than an 80-year-old man still kicking, cause they live.
Alright, so for the last example, we're going to find all scalars. And again, scalars just means real numbers. Scalars, we're going to call them lambda, such that lambda times 2, 3 has length of 1. Okay, so this is our problem. Yeah, so we're going to find some scalars, there could be one or multiple, such that this vector here is a unit vector, basically. Okay, so what we want to end up with is that this vector, the magnitude of the vector is equal to 1. Okay, and we can kind of rephrase this by multiplying the lambda in. Okay, so we have 2 lambda, 3 lambda. All right, so this is our vector. That's the same thing as you see above. So we want that to equal 1. And now let's write out what this actually is. So to find the magnitude of something, you square the components. So we're going to square each of these components separately. Okay, we're going to add them and put them under a square root symbol. So we want this still to equal 1. Okay, so when we square these, we get 4 lambda squared plus 9 lambda squared, and then under a square root sign equals 1. So if we combine these together, we get 13 lambda squared under the square root sign equals 1. And I'll continue up here. So then we get this lambda actually comes out, okay? But it only comes out as, it has to come out as an absolute value, right? Because you could put, lambda could be a negative lambda, and because it's squared, it doesn't matter, right? So we have to have this absolute value when it comes out of the square root sign. And then this again equals 1. So then lambda, absolute value of lambda has to equal 1 divided by square root of 13, right? We just solved for this here. So we divide by square root of 13 on both sides and we get this. But here's where we get multiple values for lambda, for our scalar, because the absolute value of this basically means that we can have plus or minus 1 over square root of 13. Okay? Alright, so that's basically it, and we found our value for lambda, and now on the next slide I'm just going to check to make sure that this allows our overall vector to be a unit vector. Okay, so if we check that this is in fact true, hold on here, so we wanted this to be true, and we found our lambda to be plus or minus 1 over square root of 13. Okay, so let's check the first one, the first case where it's positive. Okay, so if lambda is positive, then that means that we have 1 over square root of 13, 2, and 3, right? So if we take the magnitude, we get 2 squared plus 3 squared over a 13, right? Hold on here. Something like, wait, okay, I'll just remove that. And then it'll look like this, basically, right? Because we have the 13 on the inside, that becomes squared, so it just becomes a normal 13, right? And then we have 13 over 13, and square root of that is just going to be 1. So the positive one works. Now let's check the negative one. So if we have negative 1 over square root of 13, and then our 2 and 3, if we take the magnitude, then we have the negative 13 square root under here, that's squared, underneath 2 squared plus 3 squared, all under the square root, and that also is going to come out to be 13 over positive 13 because that's squared, and then this also equals 1. So we're good. This is a unit vector, and we found the correct values for the scalar, or the scalar values for lambda. Okay? Alright, I hope that helps, and I'll talk to you in the next video if you watch.
To the hottest niggas just to stay hot. I'm one of the hottest because I flame drop fire, and not because I'm name dropping, Hall of Fame dropping. And I ain't taking shit from nobody unless they OGs, cause that ain't the way of a OG.